Okay, so we'd like to welcome you back now to the third day of our course over this weekend on science, religion and atheism. And we've been having a wonderful time at this course over the weekend. The aim of the course is actually not to have a discussion about the existence of God, obviously that comes into the discussion from time to time, but more to consider the question about how different people coming from different perspectives, either from an atheistic perspective, an agnostic perspective, theistic perspective, talk about the science religion discussion as applied to particular topics within that discussion. And we're very pleased to have Professor Conway Morris with us this morning. He's here in Cambridge. He's Professor of Paleobiology. He's a Fellow of the Royal Society. He's worked extensively on the Burgess Shale, and I'm sure many here will be familiar with his own outputs in the research area of paleobiology. He's also done a lot of TV work, gave the Royal Institution lectures some years ago, and has an excellent book on the bookstall, Life Solution, Inevitable Humans in a Lonely Universe. If you haven't seen that, I hope you'll pick up a copy of that after this lecture. And so Simon's going to be speaking to us now on does the evolutionary narrative tend to support theism. Okay, thank you, Simon.
And then also, just to continue, as you can see, I'm asking, does the evolutionary narrative, or rather I was asked to ask, does the evolutionary narrative tend to support theism? And we could probably conclude the lecture immediately by simply saying, no, of course it doesn't. Anybody thinks that? Well, never mind. What I think one can do, though, is suggest that various areas of scientific inquiry will lead you into areas which are deeply problematic. Physicists are more comfortable in this area. I think the biologists aren't less than. And then physicists tend to be about a century ahead of biologists. And then, if that's the case, if indeed it turns out that one is entering areas which I think are actually literally incoherent, then we are allowed to take pause for thought and consider where we might develop the argument in our future. So I think we've actually got quite a lot to play for at the moment. This gentleman has already been introduced many times in the past. The old boy is 202 or 203 now. And the first thing to stress, just in case there are any residuals out, and I hope there isn't, he's right. There's no question at all about the reality of evolution. And indeed, I think principally in terms of mechanism, he was also completely correct. I think there are a couple of things worth mentioning in parenthesis. I mean, the first is that, in my view, though it's not one widely shared by experts in the history of science, in fact, the principal reason he wrote The Origin was to destroy Paley's argument conclusively and forever. And I think Paley is a ghost at the banquet, myself, and there's a couple of lines of evidence to suggest that. And second of all, I find it very striking, and maybe slightly echoes what we heard earlier this morning from Fern, is that if I remember correctly, I'm older than I appear, you'll be pleased to hear, but thinking back to older celebrations of whatever centenary or 50 years and so forth, the one a couple of years ago seemed to me to be marked by quite remarkable frenzy. The other ones were sort of nodding along and so forth, but this one seemed to have a sort of additional sort of, how do I put it, peroxide value, which was really quite surprising. And I think, in fact, tells us a great deal about the society in which we're presently living. And one of the reasons why, of course, this is a matter of considerable interest, and again, it's already been referred to by Fern this morning, is that starting, and I simplify enormously here, but I think this man, Thomas Henry Huxley, here enthroned in the Natural History Museum in sort of sub-Romanesque architecture, was very much the agent of trying to explain that if we were going to take evolution seriously, then it would become increasingly difficult to accept that we had any special place in creation. And I think, to a certain extent, I've not read Huxley extensively, he does a fair amount of dodging and weaving. And I think, like Darwin, to be quite honest, he was no philosopher. And he was often straying to areas which were really best left to people who had the training in that particular sense. But he certainly shows a degree of virulence and dogmatism which accompanies us to the present day. Not perhaps to the same level of viciousness which we see now, but even so, he was a man which, despite his coining the word agnostic, was, I think, one who was largely a life filled very largely with certainties, at least so far as the science was concerned. In terms of other things like the death of one of his children, then it was a very different story indeed. Very remarkable man, but I think we can trace much the roots of our present dilemma to Huxley and in a certain way to Darwin as well. So that's a sort of introduction, if you like. And of course, in a certain way, again, as we've already heard, this story has continued. And what I want to try and deal with a little bit now is where we might go in the future. And a good deal of my thinking was catalysed by this book by Stephen Jay Gould, which, as you can read yourself, is on an eyesight test, called Wonderful Life. And Gould was very generous about the work which I did with Harry Whittington and Derek Briggs in particular, and was mentioned in passing, about the Burgess shell and the like. And the thoughts I had at that time were, when I was first working on these fossils, there was such a diversity of types, and they were so difficult in certain cases to ascribe to known groups, which zoologists normally call phyla, that it was very probable that, as Gould himself argued, were we to, quote, rerun the tape of life, then we would end up with a biosphere, but it would be one which, so far as we're concerned, is entirely unrecognisable. And that's something which I thought we would point to, and indeed I think I may take some very small credit in Gould adopting that idea and running with it. The only problem, so far as Gould is concerned, or perhaps it's my problems, I then changed my mind. And of course, changing your mind is not a good idea. I believe Wittgenstein did as well, but that's different, I suppose. So the point then is that Gould in particular would argue that this chap here in his underwear, that's a human, is a complete evolutionary accident. And this is actually a central point of belief, disbelief by the way, in neo-Darwinism, and it is articulated, I think, by practically every biologist I know, and therefore once again I stand alone. So people like Jared Diamond, G.G. Simpson, and I'm sure some of the luminaries of today would say, as Gould indeed argued, that so many are the twists and turns which connect us from even the Cambrian explosions, the time when animal life became quite abundant, and in parentheses, of course, it's interesting, so I'm getting a bit of feedback. In parentheses, no, let's feedback, let's try over here. In parentheses was something which puzzled Darwin very much indeed in his origin, because after all we have a very protracted time of geological history where we now know we have a rather good fossil record of a sort, but even so the abrupt appearance, as it appears still to be the case in my opinion, of complex animal forms is something which demands an explanation and may be linked to changes in atmospheric oxygen or something like that. So why all this matters, of course, is that if we want to adopt broadly the view of Gould and his co-luminaries, that counterfactual worlds would indeed be radically unlike ours, and this is something which in a moment I explain is open to prediction, or actually confirmation, then we could be entitled to discuss so-called counterfactual histories. And I think this is a non-trivial exercise. This is something which historians enjoy doing. I'm not necessarily sure they do it to the highest standards, but I think in other cases they certainly do. And I particularly like, this is a cover of one of these set of counterfactual essays edited by Robert Cowley. And here you can see that happy day in London, April the 14th, 1941. And you'll be pleased to know that everybody in the rally is English. So what would have happened if, in fact, the RAF had been defeated? And had indeed Halifax, not to go into too many counterfactuals, actually taken the place of Churchill, I think it's very likely we would have surrendered, in fact. And in fact, I wouldn't be here, of course, by definition, because my father would have been deported and then shot somewhere in Germany, most likely. And in this particular set of essays, there's one which very much captures many people's imagination. And it is the simple question of what would have happened, and this sounds absolutely ridiculous, but I don't think it is, what would have happened on AD 33, was it April the 4th, I think something like that, when, if Pontius Pilate had said to the prisoner Jesus, you're free, you can go, and then say, and the very best of luck. What would have happened? Well, one says in a way this is slightly trivial. I don't think it's trivial at all. There are a number of reasons to think that Pontius Pilate was not in the habit of releasing prisoners, but he was known to be a somewhat mercurial character from the little information we have. And I think, in a certain way, the world would have been completely different, or would it? Right at the end, I'll come back to this possibility, which may offend a number of you, but I have to live with that. So the point then is, with respect to future prospects, why all this matters is that, as is clear, science, at least to some scientists, is an unfinished story. This, as I say, I think is something which is not obvious in most biological circles, where I would argue quite strongly, the more I think about it, the more the current science has more or less gone into a closure of investigation. But in particular, because we now have very firm evidence of a significant number of extrasolar systems, largely thanks in the last couple of years to Kepler, but of course complemented by the regular velocity surveys and things like that. And there's good reason to think there are hundreds of millions, if not billions, of Earth-like planets. And there is good reason, most neo-Darwinians would argue, that we have the inevitability of life, and therefore we have the inevitability of evolution, and therefore, as I will try and persuade you in due course, the inevitability, at least on some of these planets, of intelligence. And presumably, if there's such a large number, we have such a duration of time, recalling that a number of extrasolar planetary systems evolved some 4 billion years in advance of ours, which does raise a few questions, of course. Then given the rate at which these planets have been detected and the possibility of focusing on particular areas might show one sort of anomaly, in inverted commas, or another, then I suspect that within the next 20 or 30 years we'll have a pretty good idea whether we are alone in this galaxy or not. And if that doesn't interest you, then I give up. So my argument, again Dennis generously mentioned that, and I saw that of these 200 copies there are only about 199 left downstairs. Is this book which was published some years ago to universally hostile reviews. Well, has to be an academic. In part, I should explain, first of all, the subtitle is I actually argue that something like a human is an inevitability, but I think we're completely alone, which is a ridiculous statement. And also the title Life Solution, this needs a little bit of explanation because I was anxious that it was put in bookshops on the self-help shelves. So so it sold quite well, but I suspect for all the wrong reasons. So at the moment, I'm just finished an enormous, and I think unpublishable sequel to Life Solution, which is going to deal with one of the topics I'll return to in a moment. I'm just putting my pen to the next book, which will probably lead to my agent's final despair, which is going to suggest that, in fact, our current view of evolution is full of what I call myths. This needs a bit of unpacking. By myths, I do not mean fairy tales or anything like that. What I mean is simply, these are areas of received wisdom, which on a day-to-day basis are not examined in any particular detail. There's nothing wrong with that, because as I think Fern mentioned in passing, when you do laboratory work or whatever, you don't spend your time thinking, let's go back to basics. I mean, most poor people have to get grants and things like that. And you will also be relieved to hear that I'm not going to go through these in one-by-one detail, but here and there I'm going to refer to such things as is indeed evolution a random process. Of course it's not. What do I mean by skin-deep differences? That should come clear in a moment. Evolutionary perfection is hardly something which goes down too well with this boy here. I'll say something about the myth of missing links, and just again to reassure you, I'm not saying missing links don't exist. Of course they do, says he looking straight at the camera. What I mean by that is the way we look at these things may in fact be subtly different from what they actually tell us. So let's just start with the question of step back slightly, with evolutionary randomness. To begin with, there's a sort of, I think, a substrate of organisational principles which biology cannot escape. These, of course, are all subject to further research, and everything I tell you will probably be wrong, but nevertheless, there's an argument here for some degree of consensus. The first is, and again, it may come up in conversation afterwards, I strongly suspect that the only form of life which is possible is carbaquous, that is, it's based on carbon and water. We can argue around the Mallory bush on this if you so wish. But the nature of the carbon atom, its way of forming bonds, the nature of water in terms of its various solvencies and various other slightly peculiar characteristics suggests that they are peculiarly suitable. And we can probably extend this argument at least some way to suggest that at least the basic biochemistry, here sort of epitomised in the iconic DNA molecule, the crystallography, of course, which was solved just across the road, so to speak, linked to things such as photosynthesis or respiration, things like that. And they may well also be universals. And there are a number of reasons to think there's partly, at one level, they're a fairly straightforward chemistry at one level, but also because many of the building blocks which you need to make life are, in fact, synthesize themselves in entirely exceptional circumstances and often in a very wide range of environments. So that's not too problematic. Another thing which I think is somewhat underestimated at the moment, there's a fairly vociferous, and I must say I have much sympathy with them, a minority of people who, once again, are amongst the ultra-Darwinists, usually pilloried in one way or another, somehow letting the side down, is that we know that life is not only organised, highly organised as it so turns out, but also in many cases shows various geometries of form. And Darcy Wentworth Thompson's book, for instance, on growth and form, epitomises this sort of realisation that these geometries of life may in fact tell us something about organisational principles again. And this is taking this at a fairly straightforward level, that is the only level I can possibly understand. If we take, for instance, this beautiful Nautilus shell here, you'll know that it shows this logarithmic spiral. And one should also say that the reason why this attracts our attention, not only as a biologist and as a cephalopod and that sort of stuff, but it's also beautiful, and I think one should be unashamed about admitting that. But so far as this spiral is actually concerned, the mathematics which generates it is rather straightforward. It revolves around the so-called Fibonacci spiral. And I do want you to pay extremely careful attention to on Sunday morning as well, to the mathematical curves there. And what this indicates is the likelihood that there are very important so-called self-organisational principles. We see this in a certain respect with regard to protein folding, at least at some levels, and these themselves cannot be dependent per se on natural selection, I think. And they indicate that there are various forms which are going to metaphorically crystallise come what may. And I think this probably underpins a great deal more of biology than we currently realise. This is nothing to say that Darwin was wrong. Now, I'm not trying to say that for a moment, but perhaps there is a further dimension to the evolutionary story. And then the area which I'm particularly fascinated with, and I know a number of you have heard of this before, which I'll go through extremely quickly to persuade people to begin with that evolution is very far from random. And I should also say, in parenthesis, as often as not, when there are real sort of, hard-nosed neo-Darwinians, I gave a talk in Germany some months ago, they would start flapping their hands, they're rather good at that, and say, oh, no, we don't quite mean that. No. But the trouble is that all this stuff goes into the textbooks and goes into the public consciousness. And therefore, if one's going to convey this information, well, that may mean that one's got to end up in a series of qualifications. I think it is important to remind ourselves that the likelihood of evolution being strictly random is impossible, in fact. And one line of evidence, but there are many others, in fact, is to do with so-called evolutionary convergence. So here's my favourite example. Here we have some placental mammals. We belong to those which have a rather extended gestation period. There's another group of mammals which includes the kangaroo, of course. These are the marsupials, and the father is looking pretty proud of himself. That's not bad, that's my baby. Of course, in the marsupials, by and large, the young are born at a very much earlier stage. I'm told that in sort of, the smaller marsupials, the embryo is about the size of a grain of rice when it leaves the mother, and the like. So they're both mammals, but rather different organisations. And the two I've just shown you, of course, are herbivores, but they're also carnivores. And here we have a couple of saber-tooths. This is one which is characteristic in many areas of the northern hemisphere, happily extinct. And this is one which is also extinct, but lived in South America. And again, because I've got a lot to cover, I won't dwell in all the details, but what we see, of course, is that the South American form here is strikingly similar to this form here, but as most of you will know, the form here is a marsupial, the form here is a placental, in other words, and to drive us home. And I think this is important, in fact. This chap here is much more closely related to a koala bear, or wombat, and this chap's much more closely related to a giraffe than they are to each other. And people will point out, of course, they're not identical, I never said they were, but even so, the degree of convergence, I think, is striking. And indeed, these adjectives are used always, even in papers. I would hope they've got past this by now, but no. Papers on convergence come out around about 2 or 3 a week. And practically without exception, the adjectives they use are striking, remarkable, uncanny, astonishing. And one thinks, well, why? What's astonishing about this? This is natural selection, isn't it? Or is it? Because after all, one has this degree of similarity, then, again, thinking back to self-organisational principles, sometimes when you show a picture like this to a physicist, they begin to sort of look like this, they sort of look like an parallax. Is that a destroyer or is that a cruiser? And what they're interested in, of course, is the possibility that there are, if you like, attractors. There are areas of stable organisation to which forms will inevitably navigate. And this is perhaps one straw in the wind, but this is an area which might be worth pursuing. And to deal with a bit of shameless self-advertisement, not only to do with life solution, I'm not sure how much longer this is actually going to be up, actually, because I think we're going to run out of money, but there we go. At the moment, we've got a website called Map of Life, and it's full of lots and lots of examples of convergence, and if you'd like to go and visit it, please do. It's not really being maintained at the moment. There's quite a lot on it, and just to give you this one example about gliding animals, some of you will know that lizards and frogs will glide. Some of you may not know that snakes glide. Effectively, that is, not falling out of trees. But even more surprising, perhaps, is that some ants glide. And in fact, two groups of ants, independently at least, have learned this particular trick, and where they do it became some lovely story to teach at any level of biology. And it surprises people, though it shouldn't, in fact. Now, with regard to these examples of convergence, again to go through instances extremely quickly, what I'm struck by is not only that it's, if you like, widespread, in fact I'd say it's ubiquitous, but we find it at all levels of biology. We find it from molecular biology all the way through to behaviour. Let me show you just very quickly a couple of examples. This is revolving around a very important enzyme known as carbonic anhydrase, which is an extremely efficient enzyme. And I mention the efficiency because I'll come back to another enzyme in a few minutes which certainly is not efficient. And it is responsible for hydrating carbon dioxide as a reversible reaction. And that's terribly important because if you're going to recall backwards, it's a jolly good idea to be able to use carbon dioxide, as plants do. But also, of course, we have to expel carbon dioxide from our bloodstream, otherwise we'd asphyxiate. Similarly, carbon dioxide in our bloodstream is responsible for controlling the pH, the acid base, and if that goes wrong, then you are very ill indeed. This is mostly achieved, I'm told, in the kidneys. So the point about this enzyme is not only is it incredibly efficient, but basically, to the first approximation, all life requires it. And so me, being my naive paleontologist, think, well, fine. Day one, cell one, let's use some carbonic anhydrase. Fine, off we go. And of course, the Darwinian argument would be that then that is passed from species to species to species, so that ultimately plants and elephants both possess carbonic anhydrase, because once upon a time there was a single ancestor, as there was. The very surprising thing is, in fact, that carbonic anhydrase, this enzyme, has evolved independently 5 or 6 times. These are the 3 main, most famous examples, the alpha, beta, and gamma varieties. And the reason why we know they're convergent is actually this tiny blue dot here, which is a zinc ion coordinated with 3 histidines. And the rest of the protein, so far as anybody can tell, is basically scaffolding. It doesn't really matter what it looks like. But there's no reason at all to think these have any sort of common ancestry. And what I find so curious is that all the people who work on this, nobody, as far as I know, has said, well, why? Why reinvent the wheel? But actually, we see this, and I'll give you another example in a moment. This happens quite often. And there may be actually much more subtle reasons why this happens. These things I don't think are, if you like, accidental. But that sort of degree of convergence, as I've argued elsewhere, I think is so striking that you can actually make a prediction. And here we go. Wherever you are in the small universe, there will be carbonic anhydrase. It's not a bad prediction. It's not something biologists do as a sort of as a routine. At the other end, we have, it's a little early in the morning, I grant you, there we are, maybe a snifter before lunch, is in terms of behaviour, and again, I need to go through this quite quickly, but if you compare the way in which we become intoxicated, or as we say in this country, plastered, and compare that with the behaviour of the fruit fly, Drosophila, it turns out the behaviour, I'm not talking here about the genetics of alcohol tolerance, is actually remarkably similar. So I enjoy this stuff very much indeed. I have to say that in recent years I found that people have been adding far too much tonic. This is a great mistake. You just need a splash, no more. But so far as the fruit flies are concerned, this of course is done in laboratory conditions, and it's done with people with serious expressions of white coats and all the rest of it. And they have these large grants, and this grant was used to build this extremely complex piece of experimental kit known as the inebriometer. And what this, I should take my talk more seriously. What this involves, in fact, is something like 500 cells, each one of which contains 1 Drosophila. And as the cells move, as the flies, move around, every time they break a light beam, that registers as a speed. And I'm assuming I should check on the paper, I presume this is integrated. And then here over time, we have time on this axis here. And what happens is that at time 0, they have 4 minutes to settle down. You know, so how are you, folks? Not too bad, thank you. My wife, okay, yes, thank you very much. Then bliss, the whole of the system is flooded in ethanol fumes, so off they go. And what you notice is that the flies begin to suddenly walk incredibly rapidly. And of course, you think about a cocktail party, it's very similar, whereas when I went to a rice sober by and large, and it was chattering out, all right, and then after everybody's had their first drink, often the conversation dies down. Now sometimes this is because somebody's lost a corkscrew or something like that, but there's something of a lull in conversation. And of course the flies walking much more slowly, and then of course the flies, as time goes on, after about 3 minutes, they're walking more rapidly again, but they don't quite reach the speed they did there, and it's begun to plateau at this area here. And I think this is more or less equivalent to the time when we find our own jokes incredibly funny, and speech is getting a bit slurred and that sort of thing. And then of course the flies walk more and more slowly, and at 20 minutes roughly they die. But the point about this is, in fact, in terms of behavioural similarities between human intoxication and arthropod intoxication, it is convergent. And then I mentioned in passing skin deep differences, and one of the things which is always a problem is most biologists specialise, as they have to, so one person works on carnivores, somebody else works on diets, is that sometimes systems which look radically unlike each other turn out to be surprisingly similar. And I take this term skin deep differences in a very interesting paper by Donnelly et al. on sharp tumour convergence, which I won't be mentioning today. But this is one which I found very striking, published in Nature a few years ago. And what it involves is the octopus. So the octopus is a solitary creature, and that's actually surprising for a number of reasons. And it has 8 tentacles, of course, and these tentacles are used for obtaining food. So here in the tank, the octopus is lucky because it's been given a piece of crab or something like that. But what we then see, using high-speed photography, is in point of fact, as the thing takes the food towards the mouth, actually the arm bends in this particular way, and what is actually happening is that this muscular tube, which defines a tentacle, in fact consists of muscles which contract in opposite directions, and where they meet, they define a sort of pseudo-joint. And it turns out that this arrangement effectively replicates what we would call our wrist, our elbow, and the attachment to the rest of the body, such that this system here is effectively the same as you see in a vertebrate limb, despite the fact the anatomy is completely different. And indeed, I think this is a nice example of skin deep difference. And there's a bit of data down here to suggest you have constant proportionality between the different areas, which makes perfectly good sense. What's also worth mentioning in passing, because I'll come back to it in a moment, is amongst the other observations this group Sombre et al. Made, is that not only was this a very interesting example of convergence, but also it's one which they thought was very good indeed. In fact, they used that dangerous word, optimised. So skin deep differences are another aspect of recognising convergence, is sometimes in unexpected areas of similarity. Now, one of the lists of things I showed you was the so-called myth of missing links. And in terms, again, of public understanding of science, PUS as we know, the idea here is that this is a way of capturing people's imagination. And so when you look at the newspapers, very often they have, again, a bearded scientist and the skull and all the rest of it. And quite right too, because to the first approximation, it is only the fossil record which is going to provide this particular set of this particular information on a set of transformations which link otherwise disparate forms. So what do I mean by myth? Well, by way of explanation, let's consider one of the iconic examples of the missing link, and that of course is to do with the origin of the birds. Now the birds are quite evidently, as Huxley understood, derived from the reptiles, and there's no dispute about that. And in fact, if we didn't have a fossil record, that still wouldn't upset the basic thesis, they come from reptiles. But of course we do have a fossil record, happily, and those in the know will very much enjoy teaching their students about this fabulous feathered dinosaur, a feathered theropod dinosaur, Archaeopteryx, which is an Upper Jurassic form which is found from southern Germany, from the famous Zollernhofen limestone, and there's around about, I don't know, 16, 20 specimens now. And here they are shown in tandem, and here's one in company of some other flying reptiles which are very distantly related to them. Of course, these are the pterosaurs. Now, if we look at the phylogeny of Archaeopteryx in terms of theropod phylogeny, and there's lots of names here which even I'm not particularly familiar with. We've got Archaeopteryx in red, And for those of you who need a little bit of orientation, here's Tyrannosaurus. Okay, they're the ones who live in the bottom of cereal packets, right? But I've also shown you two other forms here, Rhaanabis and Microraptor, again both in red. Let's have a quick look at them. Well, here's Rhaanabis. This is from the Upper Cretaceous of Madagascar. It's found as disarticulated bones, so you might think this is a rather fanciful reconstruction of a flying animal. But one of the reasons to think that it must have had feathers, as indeed did many of the theropods, is there's a series of little knobs along this part of the limb which are absolutely characteristic of insertion points for what are called the primary feathers there. That, combined with its small size, persuades the majority of people that this is most likely an animal which flew. Microraptor is fortunately preserved with feathers and is known most spectacularly from China, from somewhat earlier Cretaceous deposits, lower Cretaceous. And Microraptor has attracted a great deal of attention because, of course, it does not have two wings, it has four wings. And this has led to a lot of interest as to whether, in fact, flight necessarily began in a sort of quadrupodal mode rather than a bipodal mode, if you like. Now, there is some discussion as to whether Microraptor was just a superb glider or whether, in fact, it was actually capable of powered flight. The jury is still out in this respect. There's now effectively no doubt at all that it lived in trees from a rather clever piece of evidence. The point about all this is that if we then go back to this version of theropod evolution, we can see that independently, 3 theropods took to the air. Now, there's nothing surprising about this, in fact. But what it suggests is that by the time we get to this stage of evolution, then, for all intents and purposes, birds are an inevitability. They're going to happen whether you like it or not. Now, I don't have time, and certainly if discussion leads that way, I can unpack this further. And in one way, this should not surprise us, because these dinosaurs were all bipedal, so they have 3 forearms. Many of these dinosaurs, even deep down, have all sorts of body covering, which is suitable for modification into feathers. And many of them tend to be relatively small. So it's, again, not rocket science here. But it does suggest, and I think this is generally true of evolution, that once you get to a certain stage of organisation, then the next stage, in hindsight, is in inevitability. Now, moving very quickly on, in terms of areas of perceived Darwinian evolution, another one which interests me very much indeed is the idea that things are not very good, they are extremely good. In fact, they are maybe as good as they possibly can be. And this is something which I think it's fair to say very much runs counter to received Darwinian wisdom. And the reason is perfectly straightforward, because Darwin showed that you need to be as good as you should be in your local context. After all, we don't have to be any better than that. We know that evolution isn't trying to go anywhere. But when one begins to look at some of the evidence, it turns out that for one reason or another, optimization may be more frequent than we had thought. To give you a couple of examples, what's the most abundant protein on the planet? It's a carboxylase known as rubisco, and it's found in plants. And the reason is that if we look at the rubisco, this is the protein here, it's essential for photosynthesis. But the problem with rubisco is that, unlike carbonic anhydrase, it is a walking disaster. And again, if you want to have a counter-argument against the intelligent design movement, and I'm very happy to engage in that counter-argument myself, then rubisco is hopeless. And the reason, in part, is that in the process of this sort of photosynthesis, free oxygen is released. And what poisons rubisco? Free oxygen. Again, well, there we are. But despite all that, there are arguments recently made that, in fact, rubisco is optimal. It can't get any better, even though it's pretty hopeless. And this is important, not least because if we think we're going to increase agricultural production, then by monkeying around with this particular protein, we might be able to achieve something which nature has not managed to achieve in 3.5 billion years. But I'm not surprised. In fact, nature has achieved all sorts of special tricks, like C4 photosynthesis and so forth. But even so, something which looks at first sight ostensibly like a walking disaster may in fact be surprisingly good. Here's another example which I quite like, because this again relies on fossil record in part, not a necessarily comfortable sight, rattlesnake. And these fangs here have a rather good fossil record which goes back some 20 million years. And in a paper published a couple of years ago, it was shown that these fangs effectively have not changed for that period of time. They show, if you like, stasis. But what's interesting about this, as these people suggest, and I'm not putting words into people's mouths at all, they're saying, again, this is excellent, this is optimal, in fact. This is the perfect tooth. In fact, there's another paper written in another context, and the title of the paper is The Tooth of Perfection. So that too gives us some sort of sense that these systems here are very, very highly honed indeed. And although I'm not going to talk about it here because it's really beyond my competence, when we begin to see how cellular operations as a whole are constructed, then the chemistry of the cell is extraordinarily effective. Now, I've shown you a couple of disturbing slides so far. Hitler on a victory parade, rattlesnakes. This next slide, I think, will upset a number of you. So if you don't want to look, I don't mind at all. Just look in the window. So it doesn't matter. I'm with you here. This is science. We've got to show pictures like this, aren't we? You wouldn't, would you? Oh. This is, by the way, from a website known as Extreme Sports. The reason I introduce it here is, again, really to put the boot into the Intelligent Design Brigade, who I have to say have done me some major disservices, and therefore I'm not inclined to be polite about them now. And that is that amongst the arguments they like to use revolving around biological complexity is the analogue of the mousetrap. That is, it is obviously a man-made structure, and that if you take any part of this complex, it's a very sophisticated piece of equipment, as it happens, then the whole thing fails. And the example I like to use in biology, their favourite one, is this one of the flagellar motor here. And we can approach this argument from all sorts of ways. The idea that it's intelligently designed, I think, is simply absurd. But I think something which is sometimes neglected, which I think in its own way is a powerful an argument, is that if we look in other groups of bacteria, they too have a flagellar motor, but that has evolved completely independently. And more importantly, of course, as it so happens, we know a great deal more about where this system was derived from than we presently know about the derivation of the classic flagellar motor, which we find in the so-called eubacteria. So it's another example of convergence. Now, in terms of trying to put evolution into any sort of theistic dialogue, in the end what we want to know is how do we know? And how do we know ourselves, of course, let alone other things? How do we actually have any reliability in what we think we know? And at some level, presumably, so at least so far as we're concerned, may not apply to other things, mind you, we have to rely on our sensory system. So this is a little bit of a segue into the argument of how sensory systems actually give us some constraints. So again, very quickly, we of course are descended from a fish, or a group known as sarcopterygians, rather than as teleosts here, and we possess these camerae. So of the many sensory systems, the ones we tend to think we are most dependent upon and are most familiar with, of course, is vision. There are many other types as well, of which I'll only have time to mention a couple. And as I'm sure many of you will know, the camerae which we possess is strikingly convergent with the camerae of this group, which includes the cuttlefish and the octopus. This is a group known as the cephalopods. And again, a little bit like that saber-toothed cats, to drive it home, we are close relatives of the starfish, and this chap is a close relative of the earthworm. And we can show beyond reasonable doubt that these two, their common ancestor of this form, which lived in the Cambrian, or just beforehand, could not possibly have possessed this camerae. And I'll just say sotto voce, for those of you who are in the know, what about Pax 6? And we can come back, if you like, and give that a jolly good kicking as well, but rest assured, it's not a problem. There are other sorts of eyes, of course, some 40 plus, I think, Mike Land, I think, would suggest a figure in that order. Some are based on mirror optics, for example. But of the other sorts, the one which is probably most abundant is the one which we find in the arthropods, and this, of course, is a compound eye. And the reason it's so important, of course, is insects are very important, as indeed are their marine counterparts, the crustaceans. This is speaking slightly loosely, their marine counterparts, the crustaceans. Now, the compound eye, of course, depends on numerous lenses here. And again, an interesting exercise in terms of Darwinian investigation is to compare and contrast and say, well, is actually the camerae the same, better or worse than the compound eye? And in this particular case, one can say, well, actually, in the end, the compound eye may suffer some disadvantages because it can pack a lot of lenses on, but of course, there's a Euclidean limit to that space. And in addition, the lenses cannot be too small, otherwise they will no longer act as waveguides. And correspondingly, as Kuhn and Kirschfeld showed very elegantly some years ago, if you insisted that camera eyes were an impossibility and compound eyes were the only ones which were permitted, so requiring humans to have compound eyes, to enjoy the visual acuity, which even through my glasses and myopia, I do more than one sort of myopia so far as I'm concerned, then the size of eye you would require would be absolutely colossal. In fact, this is a minimum estimate in his chapter in the book. He suggests a figure nearer to 10 metres. And this again is important because if we're going to think about extraterrestrials who we might one day either fight or have a conversation with, or most likely both, then the ones we're going to be talking to will be looking at us with camera eyes. They will not be using compound eyes at all. Now this business of skin deep differences again is important because when we look at other sensory systems, the last time was on, there are areas, for instance, to do with echolocation, to do with infrared detection, ultraviolet vision, all those sorts of things, each one of which is convergent, by the way. The one which is particularly fascinating is to do with the olfactory system of insects, and this takes a tiny bit of unpacking, and perhaps because time is so short I should whistle through it too quickly. This is the head of a mosquito. The eyes here, of course, are compound, and by and large, in these sensory systems, be they based on the nose or on the eye or hearing, the protein involved is a classic transmembrane, 7 helices transmembrane receptor. What that means in the trade is that if we look at the arrangement of this protein, which is in part responsible for what we call a transduction of the physical signal, be it a photon or a molecule which you're going to smell, which then ultimately triggers a neuron which sends a signal to the brain to say that's garlic, discuss. Then we see that in fact they all basically use the same type of protein. Now the ones used in the eyes, of course, are fairly familiar because they're called the opsins. Now, if we go to the insects and look at their olfactory system, there are 2 things worth mentioning. The first is that you would think that the olfactory system of a mosquito is totally unlike ours. Well, at one level it is, but actually the basic way it works is identical, but convergent. And as soon as you think about it, of course it is, because that's the way the world's organised. What is far more astonishing, in my view, is that when these proteins were investigated in the olfactory system of these insects, it turned out that they have this 7 helices, which are transmembrane. But in fact, this particular protein has got nothing to do with all the other proteins. It's been recruited from a completely different source. It's actually a cation channel. And again, it's a little bit like the carbonic anhydrase. Why on earth throw away a perfectly good receptor protein and substitute another one? And there's an argument which again may come out in discussion. I don't think it works as it so happens, but even so there might be the argument that the physical environment in which these mosquitoes find themselves necessitates exactly the same arrangement, but one which is recruited from a different system. So this is a combination of both convergence and skin deep differences. And why all this matters, again, thinking back to the examples of the carbonic anhydrase versus the rubisco, is again that when we look at the sensory systems, it turns out they're not fairly good, they're fantastically good. Well, we know that, in fact, from our own hearing. But if you consider hearing as a whole, in point of fact, our ears can work to the level of thermal noise. That's the basic background rumble of atoms hitting things. We can't hear beyond that. Eyes, in principle, can detect single photons. So far as biology is concerned, that's the smallest unit in the universe. I know there's small things in that, but we don't, biology does not make accelerators. And also, if you think, for instance, of sensory systems that are very alien to ours, especially electrosensation, you consider the sharks and the rays, well, they have these very interesting structures around their heads, mostly ampullae and lensorini, which are sensitive to electrical signals, and they can detect at the level of nanovolts. And that, let me remind you, is equivalent to a torch battery, the poles of which, positive and negative, are separated by 10,000 kilometres. Not bad, not bad at all. And it's all the more surprising because, of course, if you're a shark, you're living in an electrically extremely noisy environment. Because every time somebody flexes their muscles, it produces an electrical signal. So how on earth do they detect the signal they're interested versus everything else? And again, there's a whole set of stories here which are only now being unravelled, which show, first of all, that biological systems are very good at doing this, but actually the way they do it, once we understand, is surprisingly simple. But why all this matters, again, is it suggests to me that the biological systems which we have in terms of sensory perception have reached the limits of the physical universe. They can't go any further. And that, of course, again, to return to science, is why it's so important, because science, to the first approximation, depends on instrumentation. And again, we take all this for granted, but in fact, if one considers the things like the radio telescopes and the electron microscopes and the other methods we have, our ability to see beyond these things is really very extraordinary indeed. And in a way, this, I think, is the first sort of hint that the areas we're beginning to investigate are running into some difficulty. Now, this may seem to be unrelated, and probably it is. But thinking first of all of the sensory systems, of course, we now know to a quite extraordinary detail exactly what happens between, let us say, a molecule impinging on an olfactory membrane and it being transmitted to the necessary part of the brain where it is interpreted. What, in my view, we have no idea at all is why we say garlic. We don't know. We call it garlic. Correspondingly, in a somewhat different way, it's now clear from what I understand from the physicists, that their investigations have, rather surprisingly, in the last 20 years, meant that they actually know, in a sense, less now than they did 20 years ago, in as much as they've lost about 80% of the visible universe. Not bad going, that's a pretty impressive track record. Which, of course, in a way, is very encouraging. It suggests we're dealing with unfinished business, rather than sort of sitting around congratulating ourselves, giving each other enormous prizes and that sort of nonsense. And this business about how we go about discovering the world, first of all, in terms of the evolution of sensory systems, I think has a whole series of very interesting ramifications. And in part, our intelligence and our sentience must depend on that, so I suppose. So very quickly, I just want to address a couple of remaining issues. And the first is to inquire as to the nature of the evolution of intelligence. This turns out to be far more complicated than you might expect, not in terms of that we haven't learned a great deal, we have. But once again, once one begins to pursue these lines of inquiry, one suddenly finds oneself in some pretty unfamiliar territory. And there's nothing wrong with that, but it does suggest, again, unfinished business. Now, I'm just going to concentrate very quickly on examples of convergence in terms of intelligence-related factors with the birds. One of the interesting things, of course, is birds sing. Some of them have an innate system, but three groups independently have learnt song. Very often they're taught by their dads. What's particularly interesting in bird song is that the young, very often, especially the songbirds, the young go through a so-called babbling phase, that is, they experiment with their language, which is directly analogous and convergent with the way that our young learn in their babbling. I'm not, for a moment, and that's become clear right at the end, and this then stops me at 1:30, I'm not going to try and equate vocalization with language, as it happens. The other thing, which Alison Dupe and others have shown some years ago, is that the basic neurobiology of the vocalization process is now pretty well understood. This too is strongly convergent with what we see in mammals. In some ways, even more spectacularly, thanks to work by a group in Oxford and also people studying them in the wild, the New Caledonian crow, and we know that the crow group, the corvids, are sort of spectacularly intelligent, but the New Caledonian crows are particularly interesting because, of course, they develop these various tools. This one is a probe. Basically, what they do is, you can tell the focus, but the back, there's pandandus, which is a sort of grass-like form, really, and they craft these probes which they insert into rotten tree trunks in which live large beetle grubs, and the beetle grubs don't like to be disturbed, understandably. They think they're safe, and they get probes coming like this, and the beetle grubs have got these big pincers, and they say, like that, and they hold on to the thing, and of course then the crow carefully lifts them out. And the point about this is that this degree of tool making seems to be far superior to anything that a chimpanzee can achieve, but of course has been arrived at independently. And as Nicky Clayton and Nathan Emery, showed in a nice paper some years ago in Science, and this is all work in progress, of course, the cognitive world of the corvids and the parrots, and possibly the hornbills as well, matches basically one-to-one with what we see in the great apes. And so things like the famous string pulling experiment where they've got to work things out, or where they've got to carry a tool from one place to the other. This shows effectively a direct cognitive convergence, which suggests that at some level they've got the same sort of mind. And we again now begin to take that for granted, but one could step back and say, no, there's no particular reason why they should, is there? And the reason we might be suspicious that there's one sort of mind is that if we go to the cetaceans, the toothed whales in particular, and the amenable to us, though not to other fish, the dolphin, here too, the various experiments which have been done over a number of years suggest that the cognitive world which this primate possesses is effectively identical to the cognitive world which this dolphin possesses. Now, at first sight, you might say, well, that's less surprising, because after all, blow me down, they're both mammals, aren't they? Yes, they are, but to begin with, the roots which separate us from the whales is very deep indeed. This is basically, these things are closely related to hippopotamus and things, and cows, as I said, happens. But more importantly, these animals live in an oceanic environment. They don't have hands, they of course have flippers. They use echolocation. And yet, despite all that, one might say, well, crows and humans, until us very recently, lived in trees, so we might not be surprised we end up with much the same cognitive substratum. But you might not expect the same thing in the dolphin, but indeed we do. Now to wrap up and to move into some much more controversial territory, which will not please everybody here. Despite all these things which suggest that there are a limited number of destinations in evolution, and despite the evidence, I think, that we can now suggest that something of a human-like form is very much on the cards, and again, one can defend this from various lines of evidence. The fact of the matter is that as a species, we are now completely different from anything else on the planet, completely. And the caption which I always give to this particular slide is, what other species would think this is a sensible thing to do? It's ridiculous. And the Darwinian explanations as they are is to say, well, there's more or less a seamless extrapolation between apes, in our particular case. It didn't really matter where, you know, if we came from daffodils, it really wouldn't matter very much. In the sense of evolutionary continuity in ours, is that we are, if you just like, an exaggerated form of what has preceded us. And at one level, that obviously is correct. It's got to be. We have fossil evidence, we have molecular evidence, we have everything else. I'm not disputing any of that. But the fact is that we now see the world differently. And what might this tell us? Well, it's a very intriguing question. Because if, for instance, we consider our last 6 million years of history, which is now fairly well documented, we're moving from basically this great ape here, which is around about 1 metre in height, and we've got a brain the size of a walnut, barrel chest, long shambling arms here, bipedal, grant you, and we've gone to this beautiful gracile creature here. At what point in between these two stages did we decide to invite the intervening species to tea rather than put them in the zoo? And this is actually, I think it's a non-trivial question, partly because if one goes to science fiction, one can begin to investigate how one might approach what I think is an interesting dilemma, and maybe one which faces us in the future. Now, just to give a little bit of background explanation, you may think this is a rather surprising picture because we have Davy Crockett, or his thing, and he's been attacked by a saber-toothed cat, which we know is extinct. But he's also been assisted by an Australopithecine. So what is going on? What this is from a very nice book by a chap called Harry Turtledove, science fiction counterfactual. The book is called A Different Flesh. And what Turtledove asks us to imagine is, for some reason, and this is not quite as absurd as it sounds, as we now know from the Flores hominids, that if the Americas had only been populated by Australopithecines, when the first Europeans arrived, around about 1500 or thereabouts, they're on the shore waiting for them with a bunch of our ancestors. And in essence, what he does is explore what would have happened between the first contact through to outwardly, it's a rather depressing thing, where these chaps end up as basically very superior apes being tested for HIV and the like. And this, I think, is one way, if one's going to try and begin to unpack this question, is actually sometimes something like a counterfactual might allow you to sort of define some of the areas in which you think you want to defend. And in particular, I don't know when this transition occurred. I think it's pretty recent. I mean, the evidence suggests around about 120,000 years ago. But some years ago, I was in Vancouver giving some talks, and I went to the bookshop, this is my habit, and by accident, if accident it was, Faraday, I came across this book by a chap called David Stone, and as you can see, the camera can't, I hope, called Darwinian Fairy Tales. Now, this is not a book you should carry in public in many parts of Oxford, or indeed in the environs of UCL. And the reason this caught my attention is it's written by this man called David Stone, who I never met. He's dead now, unfortunately. He's a philosopher. But to cut a very long story short, in essence, what Stone argued is that he, like me, has absolutely no problem that this little chap here is a direct descendant of some of the inhabitants of the Case Behind. No problem at all. But he said that if you're going to try and persuade me, as a philosopher, that what makes us human, and he particularly emphasises areas which are meant to be Malthusian, reproduction, and also altruism, and passing now, I think, non-trivially, our absurd love of pets. You think about these parasite-ridden animals who bring into our home, they must be mad. We take this for granted. Is that this doesn't work. He didn't have an explanation. He just said there's. He didn't even talk about stepchild. He just said there is something different about us, which implies needs investigation. Now, what particularly attracted me to David Stowe's book is, first of all, it's wonderfully well written. It's extremely amusing, and it's also deeply politically incorrect, which I prove on enormously. Equally importantly, not only is Stowe a philosopher, but he is a specialist on Hume, the great skeptic. And Stowe is a self-declared atheist. He's no truck with his religious nuts. So he's not there to try and smuggle in some set of argument. He just says, as a philosopher, as an expert on Hume and Plato and the like, I see there's something of a problem. And my own view is that I think he's right. I think there is a bit of a problem. And by the way, one doesn't have to use a religious explanation here at all. One merely has to say as a scientist that this is an area we're allowed to talk about. Whereas I've already indicated a great deal of this dialogue has gone into closure. And I'll finish with just a few very quick observations. I've got two quotes here. Oh, gee, sorry. Can I put the electronics in? To, in a way, sort of indicate why I think this is a legitimate area of discussion. This is Edwin Muir. I know a bit of his poetry. He's very interesting Orcadian, and his biography is fascinating, and he was also the mentor of George Mackay Brown. If you don't know his stories, I warmly recommend them to you. He's a wonderful writer as well. And here's a quote from his autobiography, and it's rather small, and I'm going to read it out. I know it's boring having things read to you, but there we go. You can perhaps just discern it there. But it goes as follows, and this is what Muir writes: human beings are understandable only as a mortal spirit. And here we go. They become natural then, as natural as young horses. They are absolutely unnatural if we try and think of them as a mere part of the natural world. Ellipsis. I do not have the qualifications to prove that man is immortal. In fact, I think Muir's religious views were fairly vague. But I know that there must be such proof, and that compared with it, every other demonstration is idle. It is true that human life without immortality would be inconceivable to me, though that is not the ground to my belief. It would be inconceivable because if man is an animal by direct descent, I can see human life only as a nightmare populated by animals wearing top hats and kid gloves, and painting their lips and touching up their cheeks and talking in heated rooms, rubbing their muzzles together in a moment of lust. And a little bit like Stowe, and a little bit, though I'm no expert on English, British literature, let alone any other areas, the idea that somehow this is just some, fantasy is one which I reject. I think Muir has a point. And the reason he has a point is that, as I hinted at the beginning of this lecture, it seems to me, and I could well be wrong about this, but we're now moving into areas of investigation. I've already mentioned the word garlic twice, where I think our arguments now begin to fail. They no longer work. And this is most obvious with the question of what we call consciousness. What is it inside our brains which allows us to be sentient? Now, I'm going to go through some stuff very quickly, and this is an extremely complex area, nor is it one which I'm terribly well qualified to talk about. But it's certainly the case that there are a number of people who've got it all sorted out. Now, it may be that in part, these sort of people, like Dan Dennett, for example, are simply talking about what other people are trying to say. That might be the case. But perhaps a little bit unworthily, one has to say that given the magnitude of the challenge to understand consciousness, if indeed there is an explanation, then it's a great shame that the Nobel Committee has yet not identified any of these people who will be justly rewarded for their insights. And I think there's been something, again, of a sea shift amongst philosophers from what was effectively, I suppose, though I don't know these areas very well at all, of a sort of positivism which had a degree of certainty, to one now where I think a number of them regard it as effectively an intractable problem. I don't think it is, but I think we're going to need a new sort of thinking to get around it, paradoxically. And in particular, we can do a number of things. the idea in particular that somehow this consciousness is merely an epiphenomenon, or different parts of the brain trying to make sense of things out there, I think is comprehensively negated by the reality of mathematics. Now, I'm not a mathematician at all, I can't even do sums, but if you talk to a number of mathematicians, as has been mentioned many times in the past, then in fact they would say that what they discover is out there rather than an invention. Now, by no means all mathematicians subscribe to this idea, but mathematics is a very, very peculiar area, because not only does it lead to a degree of exploration, but often apparently trivial equations, like this one here, have immense consequences. And this is true in many areas of mathematics. It impinges on our life, whether we like it or not. So that, I think, is one straw in the wind to indicate that we might want to think about other realities. And this, to my way of thinking, this again, this is, I'm perfectly relaxed about talking about this, but I'm not the least bit embarrassed or ashamed or in any way uneasy, but just to say that is not something which I'm sure many of you would want to agree with. Here's another of my heroes. This is Owen Barfield. And Owen Barfield was one of the Inklings, of course, and apparently C.S. Lewis, as one of the other Inklings, regarded Barfield as the most intelligent of them all. So, goodness me, poor, what a man. But he never became an academic. He went into his family firm as solicitor. But he wrote a number of very difficult books, which are hard to understand. But the reason why Barfield was so interesting is that he had particular views on a number of things, one of which was the nature of science, as it happens, but also on the nature of reality, and also the origins of language. And this is, again, simplifying enormously, because his arguments are long and complex, but in essence what he's trying to persuade us is that language is not simply an extrapolation of vocalizations. Language at heart is a mythopoeic enterprise. And one of the things he was interested in is especially words which often seem to have an extraordinary range of meanings, actually then in a sense become, to use a phrase by Flieger, become splintered. So I'm not explaining this particularly effectively. But why this matters is that in essence, because we are undoubtedly a mythopoeic species, and although most people regard this simply as some sort of wish fulfillment, in fact, Barfield was very influential on this man here, Tolkien, who again, I'm a great hero of this man. And the reason why this is so important, I think, is it opens the possibility that if one's dealing with the world around us, it may in fact be constructed in a way which is very surprising indeed. And even as a scientist, one can realise that in fact the limits of our understanding may be only a small fraction of what is actually there to be understood. And the reason why this is so particularly important, I think, with regard to Tolkien and so forth, and again, there are those who loathe him and those who love him, I'm afraid I'm on the latter side there, is that in his trilogy and elsewhere, one of the things which is interesting about this is, first of all, The Lord of the Rings is loathed, absolutely loathed by the chattering classes. They hate it. And I find that's not coincidental, whereas it is amongst the general population adored. And you might say, well, this is just fantasy. Well, of course it is, of sort. But what Tolkien, I think, was trying to explain, in fact, was not only that you can have a world in which you can be genuinely a sort of hero, but also the extraordinary thing about these books, in my view, is that they have a reality about them which is quite extraordinary. And I think, again, it's no accident that amongst this remarkable group of Oxford dons and friends, Lewis, Tolkien, Barfield, and Williams in particular, the idea that, in fact, one could find truth through mythopoeic thinking was something which was actually worth exploring. So let me just conclude with another quote, because I mentioned right at the beginning this essay by Carl's Ear, and the chapter is actually called Pontius Pilate Spares Jesus. And I just, if you with your permission, so I'm copyright, that you might, can you just turn it off for a second? Do you mind? Sorry, it's just, I have to be very, sorry, I'll repeat that in case you need. So what does first of all evolution tell us? Evolution simply tells us that it is the way in which the universe becomes self-aware. Second of all, we find that if we understand the evolution of things like sensory systems and intelligence, we can learn an enormous amount about where they came from and how they operate. But in my opinion, we come against fundamental problems of going beyond that particular understanding, not least in the case of consciousness. If then accepts that consciousness and mind are in some way, this is very difficult to express more clearly, independent of ourselves, at least in some form or fashion. Actually there's a good deal of evidence of that, but perhaps is obvious from mathematics, then you're allowed to think about a world which, if you like, has orthogonal realities to it. And therefore, if one has intuitions or hunches or things like that, they may not pay off. But it's surprising how often scientists depend on their hunches. Then if you step back and want to engage, if you so choose, and you don't have to, you are creatures of free will, which of course a determinist will not allow, but you are creatures of free will, then you can engage in a dialogue which would say that these religious experiences, these religions which are universal to humans, are not again simply the fear of death or whatever you want to invent in terms of a sociological set of explanation. You're welcome to if you like, but you won't get very far with that, I'm afraid, in my view. Then you can begin to see that actually you've got something to talk about. So I think on that I should probably finish with this final thing of the voyage. This is another painting by David Friedrich, and again my sense is that when you see a painting like this, it is resonant at an extremely deep level, but it is not resonant merely as a piece of God knows how I'm going to put it, but you know, sort of somehow some cultural superiority or some nonsense like this, or some sexual attraction to go to the art gallery rubbish. This is a transcendent painting, and that's all that matters. Okay, thank you.
Thank you. Thank you, Simon, very much. I lost my words. Over to you for the first question.
Very much indeed. Can you just say a bit more about that? I sort of slightly lost the points, I guess, that you wanted to draw attention to in that. And yeah.
I'm sorry, he's been dead for many years, of course, but I mean, as I was afraid, I can give you another, an equally good one by Lou Howes, actually, which says very much the same thing. I'm sure you'll find it out as well. But what Muir, as I understand it, I mean, some years since I read his biography, and as far as I can understand, he wasn't, he probably, I don't want to say he was, because at the end of the Muir Society will write to him straight away and say, no, that's wrong. But I get the sense that he was a vaguely pantheist. Okay? So he had a religious sense, as indeed the majority of people do, but it wasn't articulated. Certainly it wasn't articulated through any particular series of symbols or liturgy or anything like that. And what he's saying, first of all, is, you know, maybe I'm just reading what incorrectly, but he's more saying, you know, we are immortal, you know, whether you like that or not. Now, he may not necessarily meant that when you die, you suddenly find yourself surrounded by people with white robes on. Not necessarily at all. Again, the trouble with most of the sort of discussion one has is we have this appalling literalism. And I'm not trying to put words into Muir's mouth, but my sense is that he's saying that there's some aspect about us which does not die. It doesn't have to be a personal immortality. I'm not trying to put him in that category. I think, as myself, the evidence that's pretty good, but I should find out in a few years. You know, it's okay. What the case might be. And the idea, again, echoing what David Stove is saying, that if we simply regard ourselves as animals, and this is important because, of course, a great deal of teaching with regard to, say, sexual relationships and things like that, are posited on some extension of evolutionary psychology. And I tend to find most of this stuff, most of it does emphasise sexual behaviour, and I wonder why, because we are obviously a highly sexual species. But I find most of those arguments, when you begin to dissect them, don't hold any water at all. I mean, they're just ludicrous. And most particularly, I think it's when you're, as I said, you know, jumping out of hot air balloons or you know, engaging in 3 hours liturgy. I mean, anybody that in a right mind regard this as absolutely absurd. I mean, many people do this, and I think he's trying to say that if we are simply animals, then life is a nightmare. And this, I think, is something which, if you make various political decisions, you can go in one direction or another. So, again, I'm sure firmly agree with you on anything I said, but I think the fact of the matter is that one enters into a political drama. So I'm not sure that's telling you any more than Mr. Muir said himself.
Yes, Jim.
Well, thank you. That was an extraordinary talk. I wanted to just see whether I'm understanding correctly a larger picture that you might be offering us of the evolutionary process with respect to humans. Because if I understood the main body of what you said about convergence, I took that to be to the point that there is something inevitable about the evolutionary process, and you've written, as you pointed out, about this. But when you came to humans, you seemed also to want to say there is something fundamentally mysterious about the relationship between us and our closest living relatives. Are you then implying, or wanting to imply, that this process of which we're part has some hiatus or some abrupt, something different? Obviously you've answered my question, no. So what are you trying to say about us in relation to our closest living relatives? Why are we, in your view, so similar and yet so obviously different from our closest living relatives?
Well, I don't have the explanation per se. What I'm, again, with great respect, I mean, the trouble is, and I know this when I talk about evolutionary myths, and one of my other favourite kicking horses at the moment is mass extinctions. You know, I won't go into detail about that, but I think mass extinctions are extremely important for a reason which I don't really widely recognise, so that's okay. And similarly, this area here, one tends to sort of say, oh, well, if he thinks we're different, therefore he's some sort of cryptic creationist, and this, looking at the camera, is rubbish. It is that if indeed the world around us is constructed in a way which we imperfectly understand, self-evident, and if indeed one is engaged in a process which you can look at as evolution if you wish, that's fine, it's not particularly problematic. And one might say, well, it's simply because we have brains of a certain size. I don't think that's true at all for a number of reasons. But for whatever reason, one is then in the same way entering new territory. That's all. And I think what's so interesting about my materialist friends is that, with great respect, they just put themselves in this minute box and said, well, that's it, you know, there's nothing else out there. And you think, oh, that might be true, but there's strands of evidence all over the place to suggest that's not true for the moment. And again, you don't have to import any religious thing. You can if you wish, but it's not at all trying to smuggle in a particular argument. It's merely saying that if indeed we are self-aware, and of course there are some people who think we're not. And again, actually this has a political dynamic to it in all sorts of ways, like responsibility for one's own actions. Then from the perspective that one is actually engaged, to use that dreadful sort of Google term, sort of as a search engine, then I think you can imagine oneself that once you enter these new worlds, as indeed happens in mathematics, which is a very odd example in a way, then one suddenly finds one ends in a whole set of fruitful dialogues, and there's a parallel argument to do with music. Exactly the same sort of argument. I mean, they're in their different sort of ways. I'm neither a musician nor a mathematician, but at one level, both of these are completely useless, utterly useless. They're stupid. They shouldn't be they're not worth the time. And yet, they make us human. And I think, again, one should be entirely unembarrassed about this, because once again, the general idea is it's not to say that we should be irresponsible for the treatment of other species, very much the reverse. But some of the experiments at the moment, and this is very, very controversial, it's work in progress. In fact, there was an article in Science about 2 weeks ago to do with animal behaviour, and the jury is definitely out on this. But there is a considerable body of thought now to suggest that a number of animals have what's called theory of mind, and this involves things like mirror self-recognition, various ways in which they understand what some other individual is doing and responding to it in a particular way. But there are a few straws in the wind, and this may all turn out to be changed in 5 years or less, but there are a few straws in the wind to suggest that these animals don't actually understand. They're intelligent, they learn, they have memory, they're not stupid, they're not suggesting any of this. They have emotions, that's fine. It's not trying to turn them into robots. But some of the experiments you can do, or so-called transfer experiments, may indicate that they are not actually rational. And if that's the case, and I'm not sure when they'll ever prove it, because of course we can't talk to them, which then goes back to the problem which I think Owen Barfield was so effective about, as to what is the nature of our language, which that too is infinite. and allows us, to keep on inventing new things. Most people think, oh, well, this is just a sort of vague sociology, power relationships. Well, that's all true. And most of the power relationships we've seen in the last 10,000 years have been vicious and unpleasant, beyond a shadow of doubt. But that doesn't necessarily negate the reality that this language is not simply a series of local verbal inventions. It is articulating realities, as music does, in an imperfect way, but nevertheless is taking us to something which is different.
Please, yes, yeah.
Thank you. The examples of convergence that you gave were amazing.
Handpicked.
Yes, I just wondered, going back to the title of your talk, does convergence support theism?
Yes. No, I don't think it does, because, I'm not a philosopher, and this is risky ground. I don't think there are any proofs at all for God, the existence of God. I don't think there's anything at all which will persuade, except for the very simple reasons I understood the previous speaker. She, with great respect, is utterly persuaded in the opposite direction from me. She's clearly a rational individual, a shadow girl. No, I think the danger here is that we end up looking at our opponents as mortal enemies and deriding them, and this is true on both sides, and certainly has been true of many religious traditions, which we know only too well. But the fact of the matter is that science is important because, first of all, it tells us things which are utterly surprising, and also it extends our knowledge of the world as it is. And again, we take that for granted now, but it's actually very surprising that we can do this. And my sense is that, in fact, the problem is we've now ended up in a particular system which is not conducive to learning, if you like. It's conducive to rote, rather than to actually exploration. And therefore, why this matters is simply it opens the possibility of further exploration. Now, I've made very clear where my religious persuasions lie, and I think I can give you perfectly good evidence for that. But people on the other side, or indeed no religion, would be equally happy to give perfectly good evidence for theirs. And, they are very difficult to accommodate. So that's, I think, all I can usefully say. I'm not trying to dodge this one. I'm entirely unashamed of where I'm standing. But I don't think I have a single right to say that the other person must be wrong.
I have an advantage rubbing his nose over the channel. So, yes, okay, yes.
I wondered if you could talk a little about the distinction you seem to be making between intelligence and rationality, how consciousness fits into this, because we have these crows showing very intelligent behaviour. But coming out of a brain that tiny, it seems to suggest if they have a worldview, it's very different from anything we can imagine.
Well, it seems not to. But the first thing, I'm mostly talking about areas, everything unfortunately I've been talking about is other people's work, so it does have a particular degree of reliability, if I'm going to say, is that, of course, the bird itself is much smaller, and there's a ratio between body mass and brain mass, which is known as the incentivization quotient, you probably know, and this scales to, normally the experiment is put at 0.67, so it's not isometric. And just as we are way above in terms of our incentivization quotient, in fact, the crows have disproportionately larger brains than the other birds. Though, again, this may sound irrelevant, but it may not be completely. In fact, birds which otherwise you wouldn't think are particularly intelligent certainly show intelligence, and the pigeons, which of course are very amenable in terms of being experimental animals, have all sorts of clever things. There's a wonderful set of experiments whereby they were asked to recognise paintings. Okay, and they were. Let's get some probably get it slightly garbled, but what it was they were asked to distinguish, and it may have been something like. It wasn't Renoir, but it's something which was sort of identify a painting versus Picasso. Okay, and they're pretty good at that. They could sort them out. That's no problem at all. But then what they did is they turned the paintings of Renoir or whoever it was upside down, but they also turned the paintings of Picasso upside down. They were completely flunked by Renoir, but they had no trouble at all with Picasso. And also their ability to deal with numbers is pretty sophisticated. So one of the problems in this whole area is that actually there are indeed evidences of, if you like, local intelligences. They're intelligent for particular reasons because they are in their own particular context. And there's also, this is very seldom mentioned, although it's clear enough when you read the methods section, that when you have a group of experimental animals, and normally it's very few, but that's the way, 8 or 9 typically, almost invariably 1 or 2 of them are complete duffers. They never get it. Which actually I think is non-trivial again. They're what we would call stupid. They're perfectly nice chaps, but they're not terribly bright. So when we go then back to these apparently extremely intelligent examples, such as the crows and the parrots, the problem there, I think, is in part, as you identify it, because when you look at the structure of the bird brain, although it's fundamentally a vertebrate structure with a cerebellum and things like that, the actual areas where the cognitive capacity is assumed to lie, discuss, is entirely unlike our system. Okay, so it's based on an entirely different arrangement. And that, in its own way, I think, is a little bit like this regressive argument as why do we know we've got garlic in front of us. And the difficulty is that with regard to these experiments, as I think I mentioned, there are a number of experiments now which suggest that they can get so far with the argument, if you like, but they're not apparently able to work it out, as we would call it, because we have this extraordinary ability, especially in science, where something clicks. And sometimes you realise that 2 unrelated things are actually together. So the difficulty, as you say, is what is the difference between consciousness and rationality and the like? And this again is a difficult area, but in fact Roger Scruton has just produced a new book called The Face of God, and he had an article in The Spectator. Oh, you should read The Spectator too. You're also a chap who reads The Telegraph. Yes, I am. He's argued again that actually they are not self-aware. There is this fundamental distinction. And this at first sight seems ridiculous because the mirror experiments are not quite as clear as you might expect. And you just say, well, this is a continuum, but it may not be. But there's something about ourselves where we certainly are self-aware, and we are able to engage in rational discourse. And it's not, by the way, to say that, first of all, any of these animals in some sense are inferior to us. They're not at all. Nor is it to say that they're not capable of what we have achieved. Because if I'm right about the argument of evolution being, if you like, a search engine to discover a rational universe, which is why science is so interesting, there's absolutely no reason why some other species can't do it. In principle. There's not a sort of, one doesn't have to say we're especially favoured, if you like. But I'm sure these animals are conscious. And actually the question of how deep consciousness goes, I mean, Rupert Sheldrake's, again, published quite an interesting book very recently, and if I understand his arguments correctly, he's sort of more or less taking a pantheistic argument, that this thing goes back, almost indefinitely. Whereas I don't think that's, with great respect to him, because I think, although this has a reputation as something of an iconoclast, I think, nevertheless, he's an extremely original individual. And again, he's a good chap to read, even if you disagree with everything he says. He's a person who provokes you to think why he must be wrong. So that's not articulating terribly clearly your point, because everything you see about these intelligent animals says they're the same as us. But actually, they're not. I don't think they are.
Okay, I think we've got time for one more question. Yes.
Would you say that creatures such as corvids have the kind of intelligence that computers can manage, rather than the intelligence that people have, and computers really don't seem to be able to manage?
Well, what's the word that computers are intelligent?
Well, that's what I mean. I mean, they don't.
No, I guess that's part of Scruton is a very interesting philosopher as well. I mean, I don't know. I don't think they are. I think computers are something completely different.
So even a corvid behaviour couldn't be effectively programmed into a computer?
I don't think so, no. No, corvids are conscious. Corvids have emotion. They have all the things we have. But what they have not achieved is to see the world as a rational structure. They have the potential to do it. And of course we, in a sense, I mean, one of the things which is very striking in Cambridge, in particular, is most people in the university are extremely clever. But in fact, there are a number of people I've met in my life who, you're just completely in the shadow of. I mean, I don't know, right. These people are logarithmically more clever than I am. And, of course, we, in a sense, have to And that's just the way, it's good luck. I mean, good luck to them. I don't no quarrel with it, but again and again you come across these people because you have an extraordinary set of insights into the way the world is.